Have you ever had mayonnaise on a burger? Or on a hot dog? Surely you've at least had milk before, right? Or maybe you've had a salad with vinaigrette if you're feeling fancy. Now, all of these things are possible with the process called emulsification. You'd probably expect this to be named after a white man named Albert M. Mulstein or something. Just like how pasteurization is named after Louis Pasteur. But no. You know who it's named after? Apparently no one. Because there's actually no one to credit for coining this term apart from the Latin language. Which the original one was emulgere. Emulgere. I can't pronounce Latin. I probably pronounce it like a Pokemon name better. But in all seriousness though, emulsification is the physiochemical process in which two immiscible liquids are dispersed into one another to form a more stable mixture. In the context of food chemistry, emulsification plays a crucial role in creating consistent textures and improving the stability of food. The emulsifiers, or stabilizers if you want to call them, reduce interfacial tension and prevent phase separation, thus influencing the overall microstructure and stability. Did you get that? No, probably not because it does sound complicated. But let me put it in more simple terms. Puga puga. Normal. Water. Oil. No mix. Emulsification. Water. Oil. Mix. Yay! But for real though, let me expound on it more. Because we've been talking so much about emulsification, but how exactly does it work? Well, to be specific at least. So the way it works is through a process called homogenization, where two immiscible liquids are forced to interact. The relationship between oil and water is a perfect example of immiscible liquids because, as we all know, it's hard to mix them as the oil just sits on top of the water. And that's where emulsifiers come in. These are amphiphilic, which are hydrophilic and hydrophobic molecules that contain both hydrophilic and lipophilic, which are oil-attracting parts, that help pack the oil and water molecules together while preventing them from re-emerging. Just think of it as a bridge that helps connect oil and water molecules together. And obviously, in today's world, there are a lot of emulsifiers out there, with some well-known examples being egg yolks and surfactants, which help reduce surface tension. These help with foaming stability and contribute to texture and structural integrity. But of course, why do certain foods need emulsification? Other foods that aren't just oil and water being mixed together? Well, obviously, the structures won't be as stable. For example, with mayonnaise, increasing the emulsification intensity leads to a finer dispersion of droplets, which creates smoother textures and more stable products. And that's how you know you've got good mayonnaise, when it has that smooth texture. Unlike my face. I really wish I had silky smooth skin. Oh well. Anyways, the process of emulsification can improve the texture of food, maintain its stability, and really help bring out the flavor of it. So, all in all, emulsification plays a huge role in creating a good handful of food and sauce. Mayonnaise, emulsification. Ice cream, also emulsification. Milk, I'm kidding, it is emulsification. You and your crush, however, that's a completely different story. Because there really are just some things that don't mix well together,